Good day, this is Group 9. We will report about the radar plotting. Course outcome. Students will have a knowledge about plotting materials, and also its users. Learning outcome. At the end of the session, students will be able to define plotting, determine the different kinds of plotting, and elaborate the relative plotting symbols and vector angle. Importance of the topic. To be able to have the knowledge or understanding on how it works on board a ship, and also its importance on board. Plotting. Plotting is the graphic displaying of an encounter between observer, own ship, and one or more other vessels targets, all within radar range of each other. Plotting will be done on radar plotting sheets or on reflection plotter made of plastic or glass. Primarily, it is done to determine if risk of collision exists. Secondly, where it is found that such risk exists, it is used in an effort to determine the proper and sensible actions which could be taken to avoid casualty. Radar motion display. Actual or true motion is expressed in terms of the direction and rate of the movement speed relative to the Earth. Relative motion are also expressed in terms of direction and rate of movement of one moving vehicle to another object, the latter being either stationary or moving. It is combined effect of apparent result of viewing one moving vehicle against another object. Subconsciously, we estimate the apparent speed and direction of other pedestrians or vehicles, direction of relative motion and speed of relative motion, and just our own true direction and actual rate of travel to avoid collision. Kinds of plotting. 1. Manual plotting is done manually. Two main subdivisions. A. Transfer plotting radar. Information are transferred to a maneuvering board sheets or radar plotting sheets. B. Direct plotting done right on a special plastic or glass surface over the PPI, provided the radar sheet has a reflection platter, using grease pencil to construct the plot. 2. Automatic plotting. It, it is accomplished by self-acting digital data processing equipment which is interfaced with the radar and provides audible and visual threat detection, graphic display or plot, and readouts of the parameters of the problems such as CPA, contacts true course, contacts actual speed. Two majors two major types. Number one, automated system. Use computers to process the raw data. Number two, image retention system. Use either high persistence cathode ray tubes or electronic devices such as video recorders and playback. These systems have the capacity to retain past position of contacts.
Good day, sir. I'm Decadet Rehensha, and I'm gonna explain about the relative radar plotting symbols and the vector triangle. So, this has OC. So, what do we mean by OC? It is an own course. Then, true course, the speed of own ship or OS is also noted. E is the point of origin of the own ship vector and the vector target. So R means the target ship's first observation, initial position of the contact. This is pointed by the true bearing and the range and time of observation. So if the relative bearing is taken, so change to true bearing. So what do I mean by M? M is the target ship designation. Then the RML means the relative motion line, that line connecting to R to M. This is true target relative movement in relation to own ship. So what is DRM? So DRM is direction of the relative motion, always in the direction of R to correspondence degrees. So what do we mean by CPA? CPA is the closest point of approach, the point where the target will be its nearest distance to own ship. So next is TCPA. So TCPA is means time at CPA. So next is NCPA, is the new closest point of approach. Then next is the SRM. SRM is the relative speed of the target. Then SM means actual target true speed. So this can be computed by measuring by scale the magnitude or length of the vector E to M. So CM means true course of the target. So this is found by transferring the E to M to the center and reading corresponding degrees on her direction. So next is the NRML. So NRML means new relative motion line. After deciding on the desired new closest point of approach, NCPA, or the radius of the desired danger circle, draw a line from the point of execution MX tangent to the NCPA. So next is the MX. So it is a point of execution. Then additional vector triangle. After establish the ERM vector triangle and deciding the point of execution or MX, also desired passing distance of the target NCPA. Draw the NRML line. NRML and own ship will decide the course of action to take and method to be employed for the collision avoidance. So for these solutions, an additional triangle vector diagram is plotted as follow: E R1 M vector triangle. So what do I mean by ER1? So ER1, E dash R1 is shows direction of the speed of own ship to avoid collision. So transfer the line to the center will show the corresponding true course of the ship. So R dash M, it means the show the new relative direction, the speed of the target of the ship. So transfer the line to the center to show the corresponding degrees for the direction of NRML. So what do you mean by AC? Collision avoidance course. The AS means collision avoidance speed. So the ROCS means resume own ship course and speed. So next is the vector triangle diagram. So the speed vector or the speed triangle. So the speed vector are pictures of motion taking place. They have two properties. So the properties are direction of motion and the speed of motion. So the vector diagram, as you can see in the picture, the vector diagram is made up of 6 factors. So what are the 6 factors? First is the OC, the direction from E to R. The OS, number 2 is the OS, length from E to R. So number 3 is the CM, direction from E to M. Number 4, SM, the length from E to M. Then the DRM, the direction from R to M. And the SRM, length from R to M. So as you can see in the picture, you can understand it. Then next is the target angle or TAN. So it is a relative bearing measured from CM in a clockwise direction to TBO, or the true bearing of own ship as observed from the target vessel. So 0 to 360 degrees. The formula is tan is equal to TBO minus CM. So we have picture here, the target aspect or the task. So it is a relative bearing measure from CM to TBO. So either port to starboard 0 to 180 degrees. TAS is red if TBO is on the port side of the contact. TAS is green. So red kung ano siya, red ko no ang TBO kung naa siya ang TBO ko no naa sa port side. So is TAS is green if the TBO is starboard side of the contact. TAS po green siya kung ang TBO nasa starboard side. Red kung naa sa port side. So rule for getting TAS. So this is the rule. If tan is less than 180 degrees, then TAS is equal to tan, naming it green siya. Then next is the if tan is more than 180 degrees, then TAS is equal to 360 degrees minus tan, naming it red. So ilanan na to ang kalahian na makita ra to this picture. Then that's all.
Good day everyone, I'm Decadet Tagamadas and I'm here to discuss about the time vector on how to find minutes rule to find speed and distance. So in 6-minute rule, S equals D times 10 or D is equals S over 10. 15 minutes rule, S is equals D times 4 or D is equals to S over 4. 10 minutes rule, S is equals to D times 6. D is equals to S over 6. 20 minutes rule, S is equals to D times 3 or D is equals to S over 3. 12 minutes rule, S is equals to D times 5 or D is equals to S over 5. 30 minutes rule, S is equals to D times 2 or D is equals to S over 2. Rule 7, risk of collision. Every vessel shall use all available means appropriate to the prevailing circumstance and conditions to determine if risk of collision exists. If there is any doubt, such risk shall be deemed to exist. Proper use shall be made of radar equipment of fitted and operational, including long-range scanning to obtain early warning of collision and radar plotting or equivalent systematic observation of detected objects. Application. When the contact is faster than the ownership, the effect of ownership evades action on the compass direction of relative movement is generally less than it would be if ownership were the faster ship. Note that the contact is always faster than the ownership in the up the scope and across the scope's cases. In making maneuvering decision, using the DRM technique, speed information on a ratio basis inadequate. The observer need only to know whether the contact speed is about 1/2, 3/4, or twice ownership speed. Rules for course change. The rules provide prediction of how a contact's relative plot and DRM will change as a result of a course change by ownership to the right. If course change to the left, the opposite effect can be predicted, valid in perspective for the position of the contact in a range and bearing. Rules for course change. Up the scope, the relative plot will curve to its left when ownership turns to the right. Down the scope, the relative plot will curve to its right when ownership turns right. Across the scope, any change of ownership course left or right will have little effect on a DRM until the contact's classification is changed to either up and down the scope contact. Rules of speed change. The rules provide the prediction of how a contact relative motion change with a speed change by ownership. Reduce speed. The relative plot move up the scope when ownership reduces speed or stop. Increase speed. The relative plot moves down the scope when ownership increases speed. Classification of radar contact. In a risk collision situation, the true or compass direction of relative movement must be changed Simple rules for rapid prediction of the change in the compass direction of the DRM or radar contact resulting from a course of or speed change by ownership can be available, particularly in the multiple contact situation. The rules can be used only when using established relative motion display. Using an unstabilized radar display could be very dangerous since a high degree of compass orientation is required to avoid risk of collision. Preferably, the radar scope should have high percentage. Through brief inspection of the DRMs of several contacts on the radar scope with respect to the direction of the heading flash, a contact can be satisfied as being up the scope if its relative motion in the same direction as the heading flash. Down the scope if its relative motion is special cases. RM. On-chip is stationary while target is moving. Relative speed and direction equals target, course, and speed. E to R. On-chip moving while target is stationary. Relative speed of target is same as that on-chip but in opposite direction. REM. On-chip is moving at same course and speed as target. Relative motion is zero or NIL. Target will appear fixed on PPI of on-chip. Collision avoidance procedures. Determine time of collision of TCPA. Determine vessel's status in accordance with these international rules of the road. Call the captain. Execute transfer plot to make the document on the situation. Plan when execute the maneuver 4 to 6 minutes. Establish passing distance of NCPA. Special cases. ERM on the ship course same as target ship, but target ship is faster on ship. Speed and direction or relative movement is equal to that of on ship. EMR on ship course same as target, but on ship speed is faster. Relative movement direction is opposite to that on ship. Collision avoidance method. Method 1. Change course and maintain speed. Method 2. Maintain course and change speed. Method 3. Simultaneous alternation of course and speed.
Okay. See, assumption shall not be made on the basis of scanty information, especially scanty radar information. D. In determining its risks of collision exists, the following considerations shall be among those taken into account. Such risks shall be deemed to exist if the compass bearing of approaching vessel does not appreciably change. Such risks may sometimes exist even when an applicable bearing change is evident, particularly when approaching a very large vessel to tow or when approaching a vessel at close range. Roll it. Action to avoid collision. Any action taken to avoid collision shall be the circumstances of the case admit. Be positive, make in ample time and with due regards to the observance of good seamanship. B. Any alteration of course and or speed to avoid collision enough to be readily apparent to another vessel observing course and or speed shall be avoided. C. If there's sufficient sea room, alteration of course alone may be the most effective action to avoid a close quarter situation, provided that it is made in good time and substantial and does not result in another close quarter situation. D. Action to avoid collision with another vessel shall effectiveness of action shall be carefully checked until the other vessel is finally passed clear. If necessary to avoid collision or allow more time to assess the situation, a vessel shall slacken her speed or take all way off by stopping or reversing her means of propulsion. So this is the part of lockout zone. So as you can see, the lockout zone, the first lane is 8 to 12 miles, and the second is 4 to 8 miles action zone, and third is danger zone, and last is SH, so in 4 miles. So what do we determine at the assessment zone? So first is CPA and TCPA, second CM and SM, and three status of vessel accordance with Call Reg 72. Thank you.